Now we come towards reflection through spherical mirrors. The spherical mirror may be concave or convex. So reflection through concave mirror. We have to go through the various definitions like principal focus, the pole of the mirror, the center of curvature, the radius of curvature, and the focal length. When we use this term principal focus, when incident ray strikes the mirror and it gets reflected, then it will meet the principal axis at a certain point, and that is called principal focus. And the length from principal focus to the optical center is called focal length. Then we come to the pole of the mirror. Pole of the mirror means we are referring to curvature of the mirror, and for all calculation we assume that curvature is very small. So the distance of all the points from principal focus, however, they slightly vary, but our assumption will be that they are same. Then comes the center of curvature. Center of curvature is the center of the sphere of the sphere of which mirror forms a part. And radius of curvature is the radius of the sphere of which mirror forms a part. We find that the distance from center of curvature to the optical center and the distance from optical center to the focus, that is called focal length, and from center to the optical center, that is called radius of curvature. And we find that radius of curvature is double the focal length, or focal length is half the radius of curvature. Now these facts are to be explained in the following context. So a figure is indicated. The red portion is polished surface and the inner portion is the reflecting surface. P stands for the pole of the mirror. The parallel lines which are moving towards the mirror are called the incident rays of light. The point where these incident rays strike, they are called the point of incidence. And from the point of incidence, the rays are reflected. All the rays after reflection meet at point F. So F is supposed to be the principal focus. And the distance from principal focus to the pole of mirror, that is called the focal length. C is the center of curvature. Center of curvature to the optical center, the distance is called the radius of curvature R. If we make a relation between focal length and the radius of curvature, we find that radius of curvature is double the focal length. Then we can use certain conventions. When a ray of light is moving parallel, then after striking the mirror, it passes through focus. And if a ray of light, incident ray of light is passing through focus, then after reflection, it becomes parallel to the principal axis. And any line passing through the center of curvature, and if it gets reflected, then it passes through again through the center of curvature. That is, if incident light is passing through C, the reflected light after reflection will pass through C. So these are some conventions we have to apply in the spherical mirrors. Moreover, the angle made by the reflected light with the surface, that is taken to be 90 degrees because the curvature is very small. The curved portion of the mirror is called aperture. In the concave mirror, as shown, the red portion, that is polished. So inner portion is reflecting. But if it is a convex mirror, then it is bulging to the other side, but reflecting portion will remain on the same side. Now there are certain definitions which I have already spoken. Center of curvature means the center of sphere of which the mirror is a part of it. that is called center of curvature. Radius of curvature, that is radius of the sphere of which mirror is a part, that is called radius of curvature. It is represented by C in the figure. Then comes the pole. The midpoint of the circular aperture of the curved mirror is called the pole, that is optical center. It is shown by point P in the mirror. Principal axis. The line passing through the optical center is called the principal axis, or the line drawn through the center of curvature and the pole of the mirror is called principal axis. That is, line connecting the center of curvature C and the pole of the mirror P is called the principal axis. Focus. All the rays which are parallel to the principal axis after reflection passes through a point F on the principal axis. This point F is called the principal focus, and the distance from pole to the principal focus is called focal length. Now, in the figure to the left side, a concave mirror is shown, and on the right side, a convex mirror is shown. The incident ray is striking a reflecting surface. When it strikes the reflecting surface, it gets reflected. If reflected light is extended backward towards the principal axis, where it will meet at principal axis, that is called the principal focus of the convex mirror, and this distance from P to F is called, that is, the focal length. C stands for center of curvature. There are certain conventions which we will discuss in the coming portion, that is, conventions for recognizing the images and the objects. We will use a kind of poetry for that: plus to the right, minus to the left, positive height and negative depth. The size of image and the size of object, this ratio is called magnification, or the ratio of V and U is also known as magnification. I will be taken as size of the image, O will be taken as size of object, V will be taken as the distance of image from the optical center, and U is the distance of object from the optical center. If distances are taken from the pole towards the left, they will be negative, and towards the right, it will be positive. All the portions taken above the principal axis are positive, and below the principal axis will be negative. Now, we come towards focal length. I have already defined this. That is, distance from the pole to the focus is known as focal length of the mirror. When a narrow beam of light traveling parallel to the principal axis is incident on the reflecting surface, the concave mirror, the beam after reflection converges at a point, and that is called principal axis, on the principal axis. A ray passing through center of curvature falls normally on the mirror and is therefore reflected back along the same path, as I have explained earlier. A ray parallel to the principal axis will, after reflection, pass through focus. A ray passing through the focus is reflected parallel to the principal axis.